Hello everyone. So welcome to today's class. Today we are going to discuss COA. Okay? COA. So let me check if everything is working fine. Yes. Okay. So I'm audible, right? Now let's discuss the complete COA. So COA, always the question comes for 2 marks majorly, okay? And this is one of the very important subject. If you are good with this subject, so in GATE, getting under 100 rank is so much possible. And if you are not good with this subject, then you cannot think of under 100 rank. Okay? So just be okay with this subject. Very important. At the start, you will feel like it's tough, but if you will understand the concept properly, then easily you will be able to solve this COA questions. Now, in today's class, we are going to discuss COA in a very short way. So this will be the revision class. I will note you some points which are very essential, which you should remember. I may not explain you everything in detail because I hope and I think that you all know this. Okay? So let's start with today's class. Let's see what is PC, which is program counter. And if you have any doubt in lecture, so please ask me in the live chat. I will definitely address your questions. And I want to let you know that we have created a revision series where I have discussed all the algorithm C, DSA, this part. Okay, I have discussed TOC, CD, I have discussed digital, DBMS and CN as well. So all these subjects I have covered. And now I will be discussing COA today. So please go and watch if you want to do revision in 1 hour of all these subjects. So the lectures are available in the live section. Go and watch, okay? And the best way to revise such courses, just play it in speed like 1.25 or 1.5x speed. So you can easily revise this. Alright, algorithm needed 1 hour, 1.5 hour. So that's how I have completed. And every lecture is in sequence, so you don't have to worry about it. Okay. So now let's get back to our lecture. Is there any chance of providing PDFs for the revision series, ma'am? So Monica, I hope I am pronouncing your name right. So PDF, actually these are the PDF. So directly you can take out the screenshot of every slide of the video. Okay, as such PDF plan was not there. And mathematics short note also will come very fast. So after COA, then I'm planning for maths, DMS, which is discrete mathematics, and aptitude as well. So every single subject will be there. Okay. Are you all finding this short notes, this lecture series very helpful? So do let me know in the chat box, in the live chat box. Okay, so program counter contains starting address of the next instruction to be executed. Okay, to be executed. After that, second is memory address register. Memory address register. So this contains memory address for either read write operation. Okay, now let's talk about DR, MDR and MBR. Okay, so it is data register, various names are there. Data register, now this holds the instruction or data. Okay, fifth is instruction register. So instructor register, this contains instruction which is currently executed by the CPU. Okay, after that let's see accumulator. So accumulator, it contains temporary result of the operation. Okay, what is GPR? General purpose register. So GPR, general purpose register, for processing the data. Eighth is PSW. So it stores the status of accumulator result. Okay, not particularly that, we can say that all result, not just particularly that, we can say all the result. After that, ninth is stack pointer. So stack pointer, it contains top of stack address. All right, everyone. Note this and do let me know if you have any doubt. After that, we will see steps in instruction cycle. Okay. Okay, done everyone? Now let's see steps in instruction cycle. Steps in instruction cycle. The very first step is instruction address calculation. Second is instruction fetch. Third is decoding. Fourth is operand address calculation. Fifth is operand fetch. Sixth is data processing. And seventh is result storage. Result storage. So till here, this is the okay, till third, this is fetch cycle. This is fetch cycle, and from here to here, this is execute cycle. All right, execute cycle. Now if interruption or if interrupt occurs, then after completing current execution, okay, after completing current instruction execution, the interrupt will be serviced. In between, it will not even look at the interrupt. Okay, after completing all the instruction, then only the interrupt will be serviced. And when the interrupt occurs, it push the PC value into stack, okay, as a written address, and control transfer to interrupt service routine. Alright, which is also called as ISR. Now let's see system bus. System bus. First is address line, which is also called as bus. So it carry address towards memory and IO. Memory and IO. So basically this is unidirection. Second is data line or bus. So this carry data, and this is bidirectional. Third is control line or bus. This is for carry control signal. Okay, which is individually unidirectional. Okay, individually it is unidirectional, and collectively it seems to be bidirectional. Okay, collectively it's bidirectional. So this is very important line for control line or bus. All right everyone, now let's see how the memory is represented. Okay, memory is represented as 2 to the power n into m, where n is equals to number of address lines, m is equals to number of data lines. Alright? Data lines, okay? After that, let's see the next one now. Address line specifies the capacity of memory. Okay? Data line specify the capacity of data, which is also called as cell size. After that, n-bit address lines can be represented as 2 to the power n memory cell, okay, which is range from 0 to 2 to the power n minus 1, okay, and default configuration in memory is byte addressable, and default in the CPU is word. Okay, any doubt in any of the statements? Answer everyone. Any doubt? Anyone having any doubt in all of these statements? So let's move to what is pin. Okay, let's see what is pins. So there are total 4 types of pins. So pins is what? Processor contains set of hardware pins to perform operations, right? So the very first is active low pin. Active low pin, so it enabled when input is 0 or clock pulse in low state. Alright, that is when active low pin is enabled. After that, let's see. Second is active high pin. Active high pin means it is enabled when input is 1 or clock pulse is high in state, right? Now the third is dual pin. Dual pin means it is 1, then memory operation we have to perform. It is 0, then IO operation will be performed. All right. Any doubt here in this? Let's see now time multiplexed pin. Okay. Fourth is time multiplexed pins. So it is, so this pin carries multiple meaning, but one at a time. So address pins are time multiplexed with data pin to carry the data and address, which is one at a time. Okay. Now let's understand what is opcode. Opcode is operational code. N-bit opcode can perform 2 to the power n operations. So you should know one thing, that this is a complete instruction. Let's say this is instruction, and here what happens is, this part is for opcode, and this part is for operand. Okay, so n operations, then opcode will be seal value of log base 2 n bits, right? And one thing also, if memory capacity is m, then address field equals to log 2 base n bits, and these are all the sealing values. So this is, if this is m, so here also will be m, not n. Okay, and this is sealing value m. All right, so note this everyone. We will see now elements of machine instruction. Now let's see the next one. Elements of machine instructions. Okay, elements of machine instructions. First one is operation code. Second is source, operand, reference. Third is result, operand, reference. Fourth is next instruction reference. Alright. Now if you talk about storage, so basically two kind of storage we do. The very first is register and the second is memory. Okay. Then one thing you should know that register storage is the fastest. Okay. And memory storage is divided into cache memory, main memory, and third is secondary memory. So out of these three, can you just tell which is the fastest one? Cache, of course. After that main, and after that secondary. Okay. So let's now discuss the the field in terms of fastest, storage, and in the size. Okay. Let's see this. So fastest, and here will be size. So as you all know that register will be fastest. Okay. So we will be writing here register. Cache after that main memory, and then secondary memory. But in size, secondary memory is bigger one. After that main memory, after that cache memory, after that register. Alright. That then immediate filled if n bit, unsigned range which is 0 to 2 to the power n minus 1, signed range which is minus 2 to the power n minus 1 2 plus 2 to the power n minus 1 minus 1. Okay. Let's see now instruction set register. Instruction set architecture. First is stack organization. Okay, which is OAF. Okay. Second is, so this is 0 AF, not O. This is single accumulator, which is 1 AF. Third is general register organization. Okay, in that we have register memory reference, which is 2AF. After that, register reference, which is 3AF. Alright everyone. Now after that we will understand expand opcode technique. How, if the opcode questions are asked, then how you need to solve that. So we will discuss those things. Expand opcode technique. First one is primitive instruction. Second is derived instruction. Third is further derived instruction. So this is lowest bit in opcode. This is higher opcode bit, and this is highest opcode bit. Okay. So now these are the types. So we will see these steps of expand opcode. Okay, so let's see the next one. Actually there was some network issue, but now it is all fine. Now let's see the steps of expand opcode steps. Okay, so the very first is identify the primitive instructions in the CPU. Second is calculate the total number of possible operation. Third is identify the free opcode after allocating existing instruction. Okay. Fourth is calculate the number of derived instructions. Okay, instruction possible by multiplying free opcode into 2 to the power increment bit in opcode. Okay, So addressing is a technique used to calculate the effective address. And we will see now the types of various addressing modes. So note down this. Okay, so let's see now addressing mode. First one is immediate addressing mode. Second is direct or absolute addressing mode. Third is memory, indirect addressing mode. Fourth is register, direct addressing mode. Fifth is register, indirect addressing mode. Sixth is PC, relative addressing mode. Seventh is base register addressing mode. Eighth is indexed register addressing mode. Ninth is implied or implicit addressing mode. 10th is auto decrement addressing mode. 11th is auto increment addressing mode. So this addressing mode part should be very cleared, okay? Because this is the easiest part and directly 1 mark or 2 mark question can come out of this. Just you need to understand the opcode, okay, how to divide it, how to extract the effective memory address, and that is how you need to remember all this. Also we will be discussing all this, so note down addressing modes. So let's discuss. Very first is immediate addressing mode. So operand present in address field of instruction direct absolute addressing mode. So which is operand are present in memory and address field of the instruction contain effective address. Okay. Third is memory indirect addressing mode. Operand and effective address present in memory. Okay. Instruction contains address of effective address. All right. Any doubt in this three mode? So do let me know. Fourth is register direct so this is an operand present, an operand are present, an operand is present in register. Okay. Fifth is register indirect addressing mode. An operand present in memory and effective address is stored in register. Sixth is PC relative addressing mode. So in this, see, effective address, this is A is effective address. Effective address means current PC value plus this is offset. AF is nothing but offset. Okay, it is nothing but offset value. Seventh is base register addressing mode. So here the effective address will be calculated as EA will be calculated as base register value plus AF, which is offset. Okay, note this. Eighth is index register. Index register addressing mode, which is EA equals to index register value plus offset. And ninth is auto increment, auto decrement. Okay, auto increment and decrement addressing mode. So it is similar to register indirect, in which register value increment or decrement. Increment or decrement. Okay, increments or decrements. This is correct. 10th is implied versus implicit addressing mode. All operand are present in the opcode itself. In the opcode itself. Okay. Any doubt in this, everyone? Any doubt? I think up till now it is all clear, right? So one thing you should remember, I am writing that whenever there is a constant, it is in immediate addressing mode. It is in immediate addressing mode. Whenever there is a variable, it is in direct addressing mode. And whenever there is a pointer, it is in indirect addressing mode. Whenever it's an array, it is in indexed addressing mode. index addressing mode. And whenever some reallocation is happening, reallocation it is in base register addressing mode. Alright. Okay, everyone. So you need to keep these points, remember. So let's discuss now data format. So there are two types, fixed pointer okay, fixed format and floating format. Data format. First is fixed point representation. And the next is floating point representation. In fixed, what comes? Magnitude format, complement format, okay. And floating point comes with single precision data, and double precision data. So this is 32 bits. This is of 64 bits. Okay. Signed. Here comes unsigned format, which is of 0 to 2 to the power n minus 1. And signed is signed magnitude format. So I'm just writing format. Okay. Which is of minus 2 to the power n minus 1 to 2 to the power n minus 1 like this. Okay. And complement format, once complement, one C I am writing, which is for complement, and 2's C, 2's complement. Okay. 2's complement. All right. Note this, everyone. So let's see the next one. S E M. S is sign, positive. 1 is negative. E is exponent. Okay, so E is equals to E plus bias if exponent is k bit, bias is equals to 2 to the power k minus 1, and M is mantissa. Okay. Okay, everyone. Now let's see mantissa alignment. All right. So 2 plus shift power is positive, then right alignment, which is increment the exponent, minus 2 shift minus left alignment, which is decrease the exponent, so note this, everyone. Okay, so any doubt, everyone? So we will see the next part in tomorrow's class. So today we have discussed till here. So thank you so much for attending this session, everyone. Do let me know how was the session in the comment. Okay, thank you so much.